Lesson 18 is Introduction to Quadratic Expression. So 18.1, we're just going to go into what a quadratic expression and equation is. Before we can kind of get into what a quadratic is, we first have to learn about a degree of a polynomial. So in the upper left corner, the degree of a polynomial is the highest degree of any of its terms. And then the degree of an individual term is the sum of the exponents of its variables. So there's this example polynomial on the right side over here. So this polynomial has 1, 2, 3, 4 terms. It's like the 8ab squared, the negative 3a to the third power b, 2ab, and then negative 7. Those are the 4 different terms. So before we can determine the degree of the polynomial, we want to find the degree of each individual term. So if we look at the first term, in order to find the degree of each individual term, we have to count up all the exponents. So right here where it says sum of the exponents, sum means to add. So we add up all the exponents of the variables. So if we look at the first term, it's a 8ab squared. So remember, like, the a doesn't have a variable, or sorry, doesn't have an exponent. So if there's no exponent, then it would be an a to the first power. So then we would add 1 plus 2, and this term would be a degree 3. I'm just going to shorten degree into DEG so it's a little bit shorter and easier to fit all on there. And then we'll do the same thing for each individual term. So next is negative 3a to the third power b. So the b doesn't have an exponent, so it's to the first power, and then I would add 3 plus 1, so this term would be a degree 4 from the 3 plus 1. And notice I'm only adding the exponents over the variables. I wouldn't like put an exponent over the coefficients like the numbers. I'm only looking at the exponents over the variables. And then for the fourth term, the 2ab, this is an a to the first power and a b to the first power, so I would do 1 plus 1. This would be a degree 2 from 1 plus 1. And then the last term is a constant. So technically a constant doesn't have a variable attached to it, so it would be a degree 0. So always a number is considered a degree 0. That may or may not come up. If it does come up, it won't be like super often, but just know a constant number without a variable is a degree 0. And then backtracking a little bit, the degree of the polynomial is the highest degree of any of its terms. So for the degree of the polynomial, we don't add all the different like degrees from each term. Like we wouldn't do 3 plus 4 plus 2 or anything like that. We just take the highest one out of the entire group. So the highest one out of the group is 4. So this whole polynomial would be a degree 4. So we would say degree 4 polynomial. So for the individual like terms, individual pieces, yes, you add the different exponents over the variables, but once you have all the terms, then you just take the highest one, and that's the degree of the entire polynomial, which the entire polynomial is this whole thing, all the terms together. Okay, and then moving down here, it says a quadratic expression is a polynomial with a degree of 2. So a quadratic is just a specific type of polynomial. There's like different kinds. There's like cubics and quartics and stuff like that. So quadratic is just one that has a degree 2. So for example, if I have like 4x squared plus 6x plus 1, that would be an example of a quadratic. Because this first term, if I add the exponents, there's only one exponent over the variable, that would be a degree 2. This second term, this is an x to the first power, so it would be a degree 1. And then the last term is a constant, and then that's the degree 0. So once I have all the individual like degrees for each term, I just look at the highest one, 2, which a quadratic is a polynomial with a degree 2. So this is a quadratic. And then there is a standard form for quadratic equations. You will see these formulas a lot. So there's the quadratic expression, which an expression just means that something has no equal sign. And then over on the right is a standard form of a quadratic equation. An equation is something that has an equal sign. Okay, so standard form for a quadratic expression would be ax squared plus bx plus c. So a is always the letter or the variable that we use to represent the coefficient of x squared, and b is always the variable we use to represent the coefficient of x, and then c is the constant term, which is kind of nice because it's like c constant, like same first letter. And then we call a the lead coefficient because when it's in standard form, it's that very first number. Okay, so these formulas, you'll see them pop up a lot. So ax squared plus bx plus c for an expression. And then for an equation, it's almost the same thing. It just has an equal sign in it, so it would be equal to 0. So ax squared plus bx plus c equals 0. So same thing, a is the coefficient of x squared and the lead coefficient. B is the coefficient of x, and then c is the constant. This time it's just equal to 0. And in order for a quadratic equation to be in standard form, this does have to be a 0 over here. It can't be any other number. Okay, so example 1, rewrite the following quadratic expression in standard form. So standard form of any polynomial means that we go from the highest power term to the lowest at the end. So we always want to start for a quadratic with x squared. X squared would come first, like it does right here, and then x the first power, and then the constant. And then in this problem, we also have some like terms that we can combine, so we want to go ahead and just kind of identify what they are. So I have my negative 2x squared, but I don't have any other x squared terms, so I won't combine that with anything. I have a 6x and a negative 3x. Those both have x to the first power, so I'll be able to combine those. And then I have a 3 and a negative 8. Those are both constant, so I can combine those. But if it's in standard form, I have to make sure that I start with the part that has x squared first. So I would do negative 2x squared. And then notice the negative 2 stays with the x squared. It's coefficient, so it stays with it. And then next would be the just x to the first power term comes second. That's the bx part. So I would do 6x and negative 3x. I would want to combine those by adding the coefficient. So I do 6 plus negative 3, or 6 minus 3 is a positive 3x. And then next my constants. I'm like adding a t in there for some reason, but 3 and negative 8, or 3 minus 8 is negative 5. So I have my negative 2x squared. I combine my blues, the 6x and the minus 3x, into a positive 3x. And then 3 and negative 8 together into negative 5. And then just to kind of compare, I'm going to copy this like formula down right below it so we can see how they're in the exact same order. So we have a number in front of x squared first, number in front of x second, and then our constant third to finish it off. And then one thing to keep in mind before we move down to 18.2 is, let's say I have a quadratic that looks like, I don't know, you don't need to write this down, but like say 4x squared minus 10. So even though this is missing something, it's missing that like kind of bx term in the middle, it's still in standard form because it has the higher power first and then it goes down in order. So it's okay if some of the terms are missing. The only like part that a quadratic has to have is the part with x squared. But if the bx or the c are missing, that's fine. We just have to make sure that we go down in order from the highest exponent to the lowest, ending with a constant term if we have one. Okay, 18.2, factoring perfect square trinomials. So perfect square trinomials, this is kind of like a new vocab word or phrase that we'll talk about. So before we do that, we have to kind of review what perfect squares are. So perfect squares are numbers like 4, 16, and 81 because we get them from taking an integer, or like that's a number, not a fraction or a decimal, and multiplying it by itself. So like 4 is 2 squared, so that's why 4 is a perfect square. And 16 is 4 squared, so that's why 16 is a perfect square. And then 81 is 9 squared. I don't know why I wrote that. 81 is 9 squared, so that's why 81 is a perfect square. So over here on the right side, that's the list of the first 12 perfect squares. So like 1 squared is 1, 2 squared 4. So all the numbers on the right side of the equal sign, those are the perfect squares. So 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. So honestly, these, I hate having to memorize things or asking to memorize things, but these numbers are really important to know. So I would say if you don't have them kind of memorized, I would make like a little sticky note or note card and write down just like exactly like this little kind of like table that we have up here with the first 12. Okay, so perfect square trinomials come in from like squaring a quadratic expression. So quadratic expressions can also be perfect squares. They're called perfect square trinomials, and they happen when we multiply a binomial by itself. So a binomial means two terms. So there's an example of this right down here. So 2y minus 5 is a binomial because it has two terms. And then we're squaring that binomial to raise the second power. Once we do that and like simplify and multiply it together, then we'll end up with a perfect square trinomial. Okay, so perfect square trinomial comes from taking a binomial, which is something like this, and then squaring it, so multiplying it by itself. So this sign in here could be like a minus or a plus, and then there just has to be two different terms on the inside the parentheses. Okay, so unfortunately we can't just like distribute this squared in. It doesn't work that way. It would be a little bit faster, but we can't because this entire quantity is being squared. So what we have to do is we have to, what's called expand it. So we would say 2y minus 5 times 2y minus 5. So the whole thing times itself. That's what we just wrote out because that's what squaring something means, is taking something and multiplying it by itself. So 2y minus 5 times 2y minus 5, and then we'll use the FOIL method to multiply these together. So we'll say, okay, 2y times 2y, 2 times 2 is 4, and y times y is y squared. That's the first term from each one. And then the O in FOIL stands for outer, so we do 2y times negative 5. Those are the terms that are on the outside. So 2y times negative 5 is negative 10y. And then the I in FOIL stands for inner, so the ones that are on the inside. Negative 5 times 2y, so negative 5 times 2y is negative 10y again. We would write a second one. And then the L in FOIL stands for last, so we would do negative 5 times negative 5. A negative times a negative would be a positive. So negative 5 times negative 5 is positive 25. And then the last little part, and we can actually just kind of fill in the next line under perfect square trinomial. We just need to make sure that we combine like terms, which are like terms in this expression are the negative 10y and negative 10y. So first I would write down then 4y squared, and then negative 10 and negative 10 together is negative 20y, and then plus 25 at the end. Okay, so our perfect square trinomial is 4y squared minus 20y plus 25. It is a perfect square trinomial because it came from squaring a binomial. And it doesn't necessarily look like anything special, but there are some kind of patterns that we can use to help us when we go to factor these. So what we do in order to factor them or to kind of like identify that they are a certain pattern is the first, we're going to get into the specifics, but kind of some quick things to look for is, the first term of a perfect square trinomial is always also going to be a perfect square. So like 4y squared is 2y in parentheses squared, because it's 2 squared is 4 and y squared is y squared. And then the last term will also always be a perfect square. 25 is 5 squared. Okay, so just one of the things that you want to kind of check for when we're starting to get more into these problems. So in general, we have a formula for these. So in general, perfect square trinomials always have one of the following forms. There's two. There's kind of like a positive and a negative version. So we just did the problem above. It was a binomial squared, so it was 2y minus 5 parentheses squared. So ours was kind of like this formula because we had a minus, but there also is a plus version. So the plus version is a plus b squared, and what that means is I have to take a plus b and multiply it by itself. And A and B, like those will be different terms depending on the problem, but this is just like our very general formula. And then what happens when we FOIL it is a squared plus 2ab plus b squared. And then for the a minus b squared is a minus b times a minus b itself, or a minus b times itself. And once we FOIL it, we would end up with a squared minus 2ab plus b squared. So these are something that if you can memorize it, great, but just you can write it down. Like you can keep it in front of you as you're working through the problem, and I would highly, highly recommend that. So what these are coming from, I'm just going to run through this really quick. I'm going to take the first line. You don't necessarily need to write this. You could just kind of follow along. So I'm going to take this part and show how it ends up being this. So I'll rewrite it over here just so there's a little bit more space. So a plus b times a plus b. And then I'm going to FOIL it just like we did in the problem above. So FOIL the first term in each parentheses. That's a times a, so it would be a squared. And then the O stands for outer, so the outside terms, a times b, so plus ab. And then the I stands for inner, so b times a. So b times a I can also write as ab because the order that I write them doesn't matter, so I kind of want it to be in the same order as the one before it. And then the L stands for last, so the last two terms in each parentheses would be b times b, which is b squared. And then I check for like terms. I have ab and ab. Those both have the same variable to the same power, so they're like terms. So I would bring down my a squared, and then if I add 1ab plus another 1ab, then together I have 2ab's, and then I bring down the plus b squared. And this is the same thing that we had up here. So it's just like showing you what happens when you FOIL it in a very general way with just the a's and b's and not like all the terms in there. Okay, so the way that we check to see like if something is a perfect square trinomial is we just want to compare it back to the formula. So we're going to compare it to one of these. I'm going to erase some of this clutter, and I'm going to take this off too. If you need it, of course, you can like go back in the video and pause it and write it down. Okay, so if we look at example 1, it says factor the following perfect square trinomial. So 16x squared plus 8x plus 1. So when we factor something, we're actually kind of going backwards from these formulas. So we would be starting here at one of these two, and then we'd be finishing here. So if I have my problem, you can kind of see it looks a lot more like these ones where it has 1, 2, 3 terms. It definitely doesn't really look like these. So we're starting on the right side. We want to go back to the left side. So the only difference between these two formulas is one has a plus on the second term and one has a minus. So I look at my second term and there's a plus there. So that's the one I'm working with. That's what I'm going to focus on, is that top line. So what I'm going to do is I'm going to rewrite the formula above this just so it's a little bit easier to like kind of compare. So it's a squared, looking at this one right here. So a squared plus 2ab plus b squared. If this was a minus, then I would pick the one with a minus, but it's not, it's a plus, so I use that one. Okay, and then now what I want to do is I just kind of want to figure out, okay, what is my a and what is my b? So in the spot of where a squared is, there's a 16a squared, or x squared, excuse me. So I have to figure out what whole thing is being squared. This simplifies to 16x squared. So as it's written right now, only the like x is being squared. So whenever you see a number in front of a variable coefficient, you have to rewrite it in parentheses and think, okay, what number squared is 16? 16 is 4 squared. So I'm going to put 4 inside the parentheses, and then x as well, because there's an x right there. And then this whole thing is being squared. These are the same exact value, like 16x squared without parentheses is the same thing as 4x in parentheses squared, because 4 squared is 16 and x squared is x squared. Okay, so now what this does is this helps me see, okay, what is my a? Oops, I accidentally erased the squared. My a is just what's inside the parentheses, it's 4x. And then I actually like to do the last part next, like the b squared part. So in the spot of b squared, there's a 1. So I have to think, okay, what squared is 1? Well, 1 squared is 1. And if you want to use parentheses, you can. I think I'm going to throw mine on there just for the sake of consistency. But if there's no coefficient, or if it's a constant term, you don't have to if there's no variable. So my b is just 1, because 1 squared is 1. And then now in the middle, this is supposed to be 2 times a times b. So it'd be plus 2. That's a part of the formula. And then next is supposed to be a, which my a was right here. It's 4x, so 4x. And then next is supposed to be b, so times 1 at the end. And then I'm going to scooch this little guy over because I got a little cramped. So this middle part is 2 times a times b, so 2. And then times a, that was 4x, and then times b, that was 1. And it's always good to double check, especially if you're not sure if it's a perfect square trinomial, that from here to here, we're not actually changing the value of anything. So like, for example, this is an 8x, and then 2 times 4x would be 8x, times 1 is still 8x. So this value is still 8x. So I'm not changing the value at all, I'm just rewriting it in the form 2ab. Okay, so that was a ton of work, but now that we did that work, it's way easier. It's not, or I don't want to say it's way easier, but now it's quick. Okay, so this is where we go from the right side of our formulas. So all the way from here over here. So going from the right side to the left side, that's factoring, and that's what this problem is telling us to do. It says factor the following. So what I'm going to do is I'm going to put the other side of the formula right here because these are equal to each other. So equals a plus b squared. That's this part right here that I'm supposed to get to. And then I already did all that work. I know what a and b are. A is 4x and b is 1. So now I can just put 4x in where a goes and 1 in where b goes. So it'd be 4x, that goes in for a, and then plus 1, that goes in for b, and then squared. So this is our final answer. This is factored form. Okay, so just for time's sake on the video, we have one more section, but one thing I want to point out is if you wanted to check this problem, our answer was 4x plus 1 squared. That means like 4x plus 1 times 4x plus 1. In order to check, you would FOIL. And when you FOIL, you should get back to your original problem. You should get back to 16x squared plus 8x plus 1, which if you FOILed this, you would. So it just tells you that you did it correctly. Okay, so definitely worth taking the time to like FOIL it back, make sure you did it right, especially on checkpoints and exams. Okay, so 18.3, this is called the difference of squares, factoring a difference of squares. So we talked about it a little bit during office hours during live, but in math, the word difference means subtraction. So when it says the difference of squares, squares means like perfect squares. So this means that we have problems where it's one perfect square minus another. And we'll talk about what exactly that means more. So 18.3, factoring a difference of squares. It's really important to remember that difference means subtraction. So think like, what's the difference between 5 and 3? 2, because 5 minus 3 is 2. And then squares is referring to perfect squares. This is the same list from up above, so you don't necessarily need to write it down again. I just wanted it to be here for us to kind of reference. So up at the top, what happens when you FOIL a plus b times a minus b? So FOIL, F stands for first, the first two terms, a times a is a squared. O stands for outer, the outside terms is a times negative b, so that'd be a negative ab because it's a positive times a negative. And then I stands for inner, so the inside terms, b times a, they're both positive, so this would be positive. And then remember, I can either write it as BA or I can write it as AB because it doesn't matter which way I order it if they're being multiplied. So I want to do AB so it's the same as the one before it. And then B times negative B is negative B squared. And then we check for like terms, and this is a like negative 1 AB and a positive 1 AB. So if I have negative 1 plus 1, that's 0. Those cancel out. They wipe each other out completely because it's just, if you add the two of the numbers, or sorry, if you add two of the same numbers that have the opposite signs, it's 0. 4 and negative 4, 5 and negative 5, 1 and negative 1. Always 0, they cancel out. So then I would just be left with this a squared and then that negative b squared. So a squared minus b squared. And this is where that difference of squares comes in. So difference, subtraction, and then squares, two numbers that are being squared. So this is the form for a difference of squares. A squared minus b squared. Okay, so next you can factor a difference of squares using the pattern a squared minus b squared equals a plus b times a minus b. So this is where our problem is going to start, a squared minus b squared, and this is where it's going to end after we factor. It's going to look like a plus b times a minus b, but a's and b's will be replaced with something different. So factoring, side note, factoring is like the opposite of multiplying or the opposite of FOILing sometimes. So if we go back to like what we just did where it says FOIL a plus b times a minus b. So let me erase some of this like highlighting nonsense just so I guess I can re-highlight it. But anyways, so we're FOILing it. We FOILed this and we got here. So FOILing goes one way, it's kind of like multiplying. Factoring is kind of like in the same realm as like dividing, so it's like goes the reverse. Kind of just like how like multiplying and dividing do the opposite of each other. FOILing and factoring in this case will do the opposite of each other as well. We're just multiplying polynomials instead of just like regular kind of numbers. Okay, so this way is FOIL. The reverse will be factoring. For this like kind of formula down here, we'll start here and then we'll factor to get to here. Okay, so example 1, factor x squared minus 16. So the first thing we want to do is we want to make our problem look as much like this as possible. So the x squared, that already kind of looks like the a squared, so I'm just going to copy that part down. And then the 16, or I'm going to sorry, and the minus. And then the 16 doesn't quite look like this b squared part, but I know that 16 is 4 squared. So I'm going to change that 16 into a 4 squared. These are the same value. So I did not change any numbers. I just changed it to like a different form. Like 16 and 4 squared are the same thing. But now I can see, I'm going to move this down a bit. Now I'm going to copy down that like a squared minus b squared formula really quick. So a squared minus b squared. I can see, okay, my a is x, and then my b, or what's in place of the b, is a 4. So b is 4. And then the second half of that formula, the part that's over there, I'm going to copy down right here. So a plus b times a minus b. And you don't have to like do this part every single time. I just want you to see how, everything's staying the same. It's the same form. It's just a's and b's are becoming like actual numbers or different variables. So when I go to factor it, it's going to look about the same. My a was x, so I'm going to put x right there and right there where a was. So x and x. And then my b was 4, so I'd put a 4 right there and right there. So one is going to be a plus 4, and then one is going to be a minus 4, and then that's my final answer. So x plus 4 times x minus 4. And then same thing here, we can check by foiling. Okay, last problem, example 2, factor 36k to the second power minus 49. So I'm going to treat this the same way. I'm going to go ahead and like copy this formula over. Until you get super comfortable with these problems, I would kind of do the same thing. It's kind of nice just to see like, okay, I plug this in here, I find A, I do this. It's just kind of a nice little guide. Okay, so the first thing we have to do, if you have a coefficient in front of your variable and there's no parentheses already, you're going to have to rewrite it with parentheses, unfortunately, because as it's written right now, only the k is being squared, so I have to think what whole thing is being squared here. So what number is being squared to get 36? That's a 6, and then k squared. So we have to think to find a, we have to think what entire quantity is being squared to simplify to 36k squared. So 6 is being squared to get to 36, and k is being squared to equal k squared. I'm going to kind of fix that 6. It looked like a b a little bit. Okay. And then the minus comes down, and then in the spot of b squared, there's a 49. So I think, okay, what number squared is 49? And if you're not sure, use this table up here. So look, like 49 is right here, and it's 7 squared. So I'm going to rewrite 49 as 7 squared. And you could use parentheses on this if you want to. You only have to use them if there's like a variable involved. So now I can see, okay, in the spot of A, there's a 6k. So A must be 6k. And then in the spot of B, there's a 7. So B must be 7. I'm going to put a 6k in for both of my A's. I don't know what happened to that parentheses. And then I'm going to put a 7 in for both of my B's. So it'll be equal to, A goes first in these two spots, so 6k goes in both those spots. And then one parentheses has a plus and one parentheses has a minus, so I'll copy that down next. So plus and then minus. And then in the last spot goes B, and B's are 7s, so 7 and 7. So 6k plus 7 and 6k minus 7 is our final answer. And then same thing here, we can check by foiling.